Hello everyone, welcome back to my channel. My name is Marcos. Today I'm bringing the continuation of our journey to learn Go. Today I'm bringing constants for if, else, and switch statements. It will be very exciting. Let's go. We'll start today taking a look on constants. So just before we take a look on the content here, just a friendly reminder that this is a repository called Go by Example that is available via GitHub. The link will be on the video below for you to clone the repository and walk through the code with us. So on constants. So here we have the constant.go open, and at the very top we see here that Go support constants of characters, string, boolean, numeric values. And we see a few packages that is being imported. Let's just continue and focus on the constants for now. So very first declaration here, outside of the function main, and this constant is a string. So it's pretty much self-explanatory. So you are unable to change that value. And on the func main, it does a few examples here. So let's just take a look one by one. The first time here, we do a print line of that value. So we expect the value constant to be outputted. And then we do another declaration here. So the same thing that you can do a var, you don't necessarily need to specify the type. You see here in the very first example, we specify the type as a string. This time, no, you just say constant letter n as the variable name and a value. When you mouse over here, you see that it actually takes Visual Code takes the comments on the top, but the very first line you see untyped int. So that's very important that the compiler and the IDE already recognize what's the actual type of that constant. And let's just continue. There's a little bit more. So here on the second one, we do constant expressions perform arithmetic with arbitrary precision. This time here, we have a float, right? So we have a float number divided by n. And here's the thing, it's not all engineers that they are used to using float. So let's just step back here a little bit to make sure that we understand what this is. This letter A here represents times 10 to the power of. What does that mean is, we use floats for high precision. So, extremely large numbers or extremely, small numbers. If you want it to be precise, floats is usually the best way. And it is also for readability. If you have too many zeros on a number, it's hard to read because you just see like 0, 0, 0, 0 is just stuff. So in this case here, I'm actually you should be see here. I'm gonna put the text what it means, but it basically means 3 times 10 to the power of 20. So it will be 100020 times. And then we divided that value by n, which is this guy right here, and we print. We need to take a look on how does it behave, because we are not specifying the type, remember? This is an untyped float. We will display as an integer or we'll display as a float. We'll execute the code in a second. It will show us. And another one here is, the continuation is, a numeric constant has no type until it's a given one, such as by an explicit conversion. So here's the thing. We do a println for both, right? For both variable d, which is the result of this arithmetic operation right here. So the first time is likely to be float, because now we are converting the integer 64 in regards to that variable. So here we'll show into a integer representation. And last but not least, just to show what it means, a constant has no type until given one, is this one right here. So letter n here, if the variable is an untyped integer. But look at what it says. A number can be given a type by using it in a context that requires one, such as variable assignment or function call. For example, here a mathsin expects a float. Yep. So if you mouse over here on the function, you'll see the accepted parameter here is a float. We do not do conversions, right? Like on n. N is presumably at first an integer at first glance, but in fact, because of the flexibility on Go using constant, it does not require you to do a explicitly conversion. It will just go ahead and just work. And this is quite nice. Let's execute it, right? So opening the terminal here. So what I'm going to do, I'm going to go to this folder, const cd examples. Oh, sorry about that. And then constants. Here we go. We are on the folder. Just to run the entire, not necessarily specify what we did in the past, right? On the past video, like we specified constants.go. We specify it right here, constants.go, and it run. Just another way to do this is just do a letter, a character dot, and by doing so, you basically say like execute the package that is available here. It's the same thing. So let's see on the output, right? So the output here, the first is constant. Well, we knew that because that's the string constant that is right here on the top. And the second one is this print line right here, which is a arithmetic operation between a float divided by this gigantic number. And as you can see here, it does a representation of, a float, right? So because you didn't explicitly convert, this is basically means, e times 10 to the power of 11. Now that we know, and then here we do a conversion to the integer 64, so that should be 11 here. So let's just count 4, 5. So let's see, 4, 5, 6, 7, 8, 9, 10, 11. Here we go. So just that number in a representation of an integer. It's easier to read if you get used to it. Yeah. Let's continue. What's the next one here? Yeah, here we go. So like the math.sin here on the constant n of this number, that's the result. And because it accepts a float, you are printing line of a float. Therefore, that's the value we have right here. And that's pretty much for constant. Let's just take a look on the next one, which is going to be 4. So for.go, let's just change the terminal first here. So I'm gonna go up one folder. I'm gonna do on 4. Here we go. Now we are on 4. I already have the file open right here on the top. Let's take a look here on how this content works. Closing the terminal first. Here we go. So yeah, so for in Go is only a looping construct. Here are some basic types of for in loops. Let's just see. So here we first assign a variable called I, and the value is 1. It is implicit to be an integer because it's not a constant, so we do have a type. So we're going to loop this 3 times, so like 1, 2, and 3, and then it's going to print this value of I. Very simple, straightforward. One thing that you notice here is there is no parenthesis and just the braces here. So like syntax-wise, it seems to be straightforward so far. The next one is a classical initial condition after for loop. We for folks that used to do JavaScript, C#, Java, we have a similar this classic syntax where you assign a variable right here. You have a condition, and then you have the increment of that value, and you iterate through that loop until this condition is met. Here we just print, we're going to see the value once again. That should be 7, 8, 9. Here's another one. For without a condition will loop repeatedly until you break out of the loop or return from the enclosing function. This is the well-known while, the while syntax. Rest in peace, while. Go does not have while as a word. Go has just for, which simplifies the amount of, the amount of words or syntax you need to remember. Just say for. So here what we do a for loop. We printed loop on the console, and we break it right away. So we execute only once. And last but not least, you can also continue to the next iteration of the loop. By using the syntax continue. The idea of the syntax continue is you skip. So let's just say you have a medium-sized business logic happening in the middle, but at certain condition you no longer need to execute the rest. You can just do a continue. It also for readability, so you don't need to add like a if statement and do else, like nested else's. By doing just a continue, you have your code identity slightly better. So yeah, so in this case here, it will just print all, even numbers. So if it will skip the even numbers, it only prints the odd numbers. Let's see if I got it right. Here we go. Let's just open this little guy right here. We do a go run and a dot on the folder of 4. And here we go. So let's just take a look one more time here. The first 1, 2, 3, it is in regards to this for loop right here. The second one is the 7, 8, 9, which is in regards to this for loop. And this next for loop here, I keep saying loop, but it's just for. And the second one, this third one is only a loop that is being printed. And the last one here, yeah, I got it right, is only being displayed the odd numbers. So because, you know, that value, the division result of that value is basically 0, then it means it's an odd number. And yeah, that's pretty much it. For very simple, straightforward. Another thing to mention is other programming languages allow you, if you have only one line, you don't need to have a brackets. Like if you remove it here, it's not going to work. So you really need the brackets there. I think it says here, does it? No, it does not. Oh, right here, yeah. And the enclosing function, no, it does not actually. I swear it did. But anyway, and yeah, that's pretty much it. So we're going to go next to the if-else statement. Okay, we're going to take a look now on the if-else statement. So yeah, let's just start on the top. So branching with if and else in Go is straightforward. So here we have the first example. So you don't have, you notice that you don't have parentheses on if, neither on for loop. So that's the standard way of the syntax on Go. And you use the braces to enclose the condition here. So you do like this. And we also have else. So this is how syntax-wise the else works. Simple, straightforward. You obviously can have a if statement without an else. So what you do is just you don't specify the else, and that's you're pretty much covered. Syntax looks exactly the same. Now this is like the difference that I notice in Go is a statement can precede conditionals. Any variables declared in these statements are available in all branches. So that means, as you see here, on the very first time, the first line of the if statement, we assign a variable. So we say, hey, number, you know, a variable num is equal 9, and then right away you do your condition. Think about readability, okay? So this might not be the most, you know, readable code because this is the first time I see, you know, a proposal like this. For the sake of example, obviously this works because we are just showing the power of if, but this is actually not a, you know, viable code because you're assigning a variable and right away you're checking the value and we know where the condition will meet, which will be this one right here. But again, just for the sake of readability, think about that when you're using this capability. But it looks nice. So that this variable num is available within each of your conditions. So we do a condition here. If it is not matched, we do a else if. This is actually the first time that actually shows else if as well. So you can use that to add another condition on the else. And lastly, you do the else itself. Let's just take a look at what it says at the end. So note that you don't need parentheses around conditions. I would say it's not only about don't need, you can't do it. Let me just test it, right? So if you do a parenthesis here, well, I saved it. Visual Code remove it right away. Maybe it's a linting thing. But yeah, you don't need it. So let's just use these best practices of not using those parentheses. And let's execute this code. Make sure that you're on the folder. I already switched the folder here to if else folder. And what we're going to do is going to do a go run this guy right here. And here we go. So the first switch statement, Windows is complaining about my compiler. That's fun. Okay, let me just close it up for now. So yeah, so 7 is an odd number. So that's the first condition that we have here. The second one is 8 is divisible by 4, which is, you know, this condition is true. And the last but not least, we already knew the result is 9 has 1 digit. And this is pretty much, we pretty much covered for if else. Let's take a look on the last part of this video, which is the switch statement. Switch statement. So first, as always, let's just switch the folders here. So we're gonna switch to switch statements folder. Here we go. and close the terminal. And I already have the switch ready to go here. Let's go all the way to the top and let's see how this works. So for those unfamiliar, switch is just another way of adding conditions, but for the sake of readability, you add it in such a way that is make it easier to read, but you can accomplish the same things that you do with a switch with pretty much with a standard if. Yeah, let's take a look here on the top. So switch statement express conditions across many branches. We have some packages being imported. We're going to see how this is being actually worked. So the very first example here is a basic switch. We assign a variable, which is an integer of I. The value is 2. We print the value I as write, I as, and then likely something else will come. And here's the switch statement. So it started with switch. And let me just do something right here. It started with a switch, the variable, and then whatever the value is, you have cases. You notice here that you don't need break. Like there are some other programming languages that you are obligated to do something like this, not in Go. Not as far as I know. so yeah, actually remove the indentation. Interesting. So yeah, so that's what you do. So if it is case 1, it will do 1. If it is case 2, 2, and last but not least, you do this last one. Does it have a default? Actually, I don't know. Let's explore that at the end, okay? Okay, so let's go here on the next one. You can use commas to separate multiple expressions in the same case statement. We use the optional default case in this example as well. Yeah, I was too much ahead of myself. We do have default here. So first, we use this package called time. You got now and then weekday. This actually, returns a, some kind of enumerator. And then we do a case here. So you have multiple cases. So in case it's Saturday or Sunday, within the same condition, you do a print. And for everything else, you can have a default value. If it is not matching any previous condition, you just print it right here. That's awesome. And yeah, let's continue. So switch without an expression is also an alternate way to express if-else logic. Here we also show the case expressions can be non-constant. So we take the time now and we say if the t hour now, which is the current time on my current time zone, is less than 12, it's before noon. If it is for everything else, will be default afternoon. So the difference between the other if statement, the other switch cases here, is because it's doing a condition on the case. This is important. There might be some other language that doesn't accept this here. It needs to be a hard-coded value, but here, no, you can actually do like, straightforward conditions at least. It does accept it. It's actually quite nice. I would be careful, once again, with readability. Make sure you don't have like large conditions. Otherwise, your code might become unreadable. And let's continue here. So a type switch compares types instead of values. You can use this discover the type of an interface value. In this example, the variable t will have the type corresponding to its clause. It's presenting a few things here. Let's read the code. I wanna cover what actually is showing here so you know what's going on. So it's assigning a variable called what am I, and that variable is a function. Right, so we're not calling the switch statement right away. We have a function that can be dynamically called. And function is actually a subject that will be covered later. So I personally, think this was slightly too soon. But in any case, let's just take a look here. So you assign a variable, and the variable, it will be a function. That function is an interface. So that function has, its name is I, and the type is an interface and open and close curly brackets here. I'll show you what that is in a second. And then we have a switch statement right away. The switch statement do, hey, I'm assigning a value t, and the t will be, if you mouse over here, is the type of interface, and the value will be I.type. This is essentially the Go syntax on retrieving the type of a specifically variable. Right? So let's continue. So in other words, it can be anything here. Let me just show you. So this interface I have open right here. So what is an empty interface, right? So we have this website here that shows the empty interface. So the interface type that specifies 0 methods is known as the empty interface. And the syntax that is showing Go here is interface, and then you open and close, brackets. And an empty interface may hold values of any type. Every type implements at least 0 methods. So empty interfaces are used by code to handle values of unknown type. So it makes your code very dynamic. There is an example here on the left side. Let me just reset here. Here we go. So for example, it just is an example here, but this is actually more confusing than I explained. So let me show you here. So on the function here, it declares a variable called I, and the I is interface. So it's a now it's a variable that can hold of any type according to the description here. So and then calls a function called describe. The function describe is explained here below. So describe is a function that accepts a variable of interface, which is again holding any type, and we print a line, and the line is parentheses and %v, which represents value, and %t with capitalized T that will output its type, and we do the variable I. Let's just execute it to see how it works, right? So we have an interface, and we do a describe right away because we have not assigned a value, nor obviously there will be no type because there is no value. The first outcome here will be nil, which is equivalent for null in other languages like null. So because there is no value. But here's the thing, afterwards, we have a variable I, which is the same variable, and we assign 42. And we do the describe, which is essentially this printf and printf right here. So this time 42, integer. So we change the type. Well, there was no type, and then it has changed because, it's a type that can hold any type. It's better explained on the next one here on the line 12. Like the variable I is equals hello, but this hello with double quotes is essentially a string. So you change the type, and then we describe once again, which is a printf, and we can see the value here is hello, string. So hello, which is the variable value and the variable type. So it's just a dynamic way of having a variable like with multiple values and types. So yeah, let's just go back to the code there. Let's just open back Visual Code. So again, we have a function which is accepting a variable type of interface, which is pretty much anything. We say, hey, what is your type? And we assign to T. If your type is Boolean, we print, say, hey, I am a Boolean, I'm a bool. If it is integer, case int, and then we say I'm int, and everything else, I don't know the type. And then I don't know the type T, and again, the percentage capitalized T will have the value. But this is a function, right? So what am I is a function. So here's the thing. We call the function saying what am I, and we pass true. And this will basically end up right here. I am Boolean. And we call the function again, what am I 1, which is an integer. 1 is an integer by default. So we'll go right here. And we have the last but not least, a string, which is, well, because there is no case for string here, we'll just say, I don't know the type. Let's just execute this code. So we are on the switch. Okay, so we're already on the switch folder here. So we're going to do a go run dot. Okay, so let's go at the very top here, right? So the first one is write chew as chew. So it does a chew right here. It does a case, and the case will end up on this one right now. Okay, very simple, straightforward. Another one is we do a switch case with multiple values here. So you say time Saturday on Sunday. It's a weekend. It happens to be a weekend today. By the time I'm recording this video is a Sunday. So that's why, the time.now is indeed a time.sunday. Therefore it's saying it's a weekend. Okay, going next here, we have another capability. Instead of putting the you have a condition within the case, right? So if it is t.hour is minus than 12, then it's before noon. If it's everything else is will default is afternoon. And yes, it's also afternoon. Right now, my local time is almost 4 p.m. PST. I'm physically located in San Francisco, California, United States. So that's 4 p.m. on my local time. So just going back here, going down, yeah, so we call the function 3 times, right? What am I? True, so I'm a Boolean and an integer, and I don't know the type of string, so just calling the function here. We'll likely cover this once we start discussing about functions, but, you know, just keep in mind the switch capabilities. And yeah, that's pretty much everything that we have for today. I hope you guys enjoyed, you know, this detailed walkthrough of, you know, constants for if, else, and switch. It's been amazing. If you liked the video, please give it a like and subscribe to the channel as well. And see you next time. Thank you.